Welcome back. Let's go ahead and look at example 3, write and solve an absolute value equation. So it says A, Sydney Harbour Bridge in Australia is 1,149 meters long. Because of the changes in temperature, the bridge can expand or contract by as much as 420 millimeters. Find the minimum and maximum lengths of the bridge. And I think I forgot to read this. Example 3 is about writing and solving an absolute value equation. So these are absolute value equation story problems. So what we're going to do is we're going to learn some different techniques on how to take this information and then write an absolute value equation that goes along with this problem. All right, so let's go ahead and look at all the important information. It says Sydney Harbour Bridge is in Australia the bridge is 1,149 meters long. Okay, because of the change in temperature, the bridge can expand or contract. So what that means is that the bridge's length, it changes. It's not always 1,149. Sometimes it's longer, sometimes it shrinks and it's not as long depending on the temperature. It's kind of interesting. And then it says by as much as 420 millimeters. So it can increase in size by 420 millimeters, or it can shrink in size by 420 millimeters. So that's kind of interesting. Find the minimum and maximum lengths of the bridge. So that's what we are supposed to find. So find the minimum and maximum lengths of bridge. Okay, so that's what we need to do. Find the min and the max. All right. So let's go ahead and look at this. So we have a bridge, right? And the bridge is right here. I'm just going to mark 1,149 meters. Let's say it's that. That is 1,149 meters. Okay, what this says, it expands and contracts, which means it goes 420 millimeters this way and goes 420 millimeters that way. That's a 420 millimeters that way. Okay, so what happens is we get a new value here. When it expands, we get a new value. We don't know what that value is. We're going to call that x. Well, this would be our max, right? If it goes in the positive direction. And then when it contracts, it becomes smaller and it becomes a new value. And it becomes x. And this is the maximum and this is the minimum. But really, it could be any of these distances in between here. But right now, we're just concerned about the max and the min. That's what they're asking us to find, is the max and the min. So what we need to know is we need to know what the difference is between these two numbers, right? So what we're going to be looking at is we're going to be looking at the difference. X minus 1,149. What the amount is supposed to be. It's supposed to be this amount, but it expands and becomes this max, or it contracts and becomes this max, which is our variable, right? But look at this. See how it's going this way, 420, and this way? Doesn't that look familiar? Yeah, that is like our two equations, right? When we split it into two and we had a positive 420 and then we had a negative 420. So that number, when it goes this way and this way, that's what it equals. It equals 420. And then this piece right here, the difference between these two values, it can be a positive difference or it can be a negative difference. So that's why this right here, we're taking the absolute value of that. So that is the equation. All right. Now we're going to go ahead and find the max and the min. So we're going to solve this absolute value equation. But I think we actually need to do something first. And what we need to do is, there's an issue because the issue is that this is in meters and this is in millimeters. So we need to convert so they are the same thing. So this quite isn't the equation yet. We will figure out the equation in a second. So let's go ahead and how about we convert the millimeters into meters? Okay. Do you know how to do that? I always memorized this when I was younger. I mean, millimeters and meters. What is that? I forget what it's called. The metric system, right? So, but this is the thing that helped me remember it all. I would say kids have dogs, mothers drink cow's milk. So this is kilometers, this is hectometers, this is decameters, this is meters right here. This is decimeters, centimeters, and then millimeters right there. So this is the order of all of the metric system. Kids have dogs, mothers drinks cow's milk. Boom. If you can remember that, you can remember the whole metric system. Then what we're trying to do is we're trying to convert the millimeters into meters. So what we do is we go where we start, right? So we have 420 millimeters and we're trying to convert that into meters. So we're trying to figure out what is that value there. So we start here at millimeters. Millimeters are here. And then it's a really complicated method called the Loopy Method. It's the Loopy Method, yes. So you go from millimeters to centimeters is 1 loop. Centimeters to decimeters is 2 loops. And decimeters to meters is 3 loops. And we're trying to get to meters, right? So you start here and then you do loopies. Yes, super technical until you get there, meters. So we know from millimeters to meters, it's 1, 2, 3 loopies, okay? So then you go to this number, you find the decimal, which is here, and then you do 3 loopies in the same direction, right? We went from here to here, so it was in this direction. So we are going to do 3 loopies this way. 1, 2, 3. Boom. That's it. So 420 millimeters is the same thing as 0.42. I don't need to write that 0.42 meters. Okay, so let's just go ahead. Okay, the decimal is right here in front. Okay, cool. Now we have everything in meters, which I think is, we need to have the same unit. So this needs to be meters, this needs to be meters. So we just need to do that little conversion first. Okay, cool, we did it. Now we have the correct, this is the correct thing. Sorry about that, I hope that wasn't confusing for you. So then we're trying to isolate these absolute value symbols, which is already done because that's the only thing on this side of the equation, which is great, right? And this, what is this? Is this a positive number? Yes, it's a positive number, which means we're going to have 2 solutions, right? So this is where it breaks into 2 equations, where we keep this same number inside. It doesn't change. So we have x minus 1,149 equals there, and then we have the same thing over here, x minus 1,149. And remember, when we do the 2 equations, those absolute value symbols drop. Okay, this is exactly the same. You don't change anything, but what we do change is this 0.42. It goes 0.42 meters now, this direction, and then in the negative direction as well. So this is 0.42 and then a negative 0.42. All right, now we just use our algebra and solve. So we're trying to figure out what x is. We're going to do the inverse of subtraction, which would be addition to both sides. And then that cancels, that's 0. We get x equals 1,149.42. Okay, then we do the same thing over here. We're going to do the inverse operation of subtraction, which is addition. This cancels out and becomes 0. We have x equals, okay, we're going to have to find the difference between those 2 numbers, and I'm going to do a little subtraction over here on the side. So, oh shoot, that wasn't supposed to be a decimal. So 1,149, and we got to find the difference between those 2. So I'm going to subtract 0.42. So you got to line up the decimals when you're adding or subtracting. 0.42, which means I need to add 2 zeros on top of there. All right, now I just subtract. I'm trying to subtract the 0 from the 2. You can't do that. It's not big enough. So I need to borrow, but I can't borrow from the 0. So I borrow from the 9, making that an 8. that 1 goes right here. So now it's not 0, it's 10. And this needs to borrow from that. So we borrow 1 from that, which would then make it 9. And then we get that 1 there. So now this is 10. So 10 minus 2 is 8. 9 minus 4 is 5. We drop down that decimal. And then we have 8, 4, 1, 1. Okay, so that's our answer. 0.58. So then we just need to find the minimum and the maximum. So this number's smaller, so this is our minimum. Equals 1,148.58. And maximum would be 1,149.42. And that is our answer. All right, great. Okay, let's go ahead and do a different example. Okay, here we go. We have B. The Sydney Harbor Bridge is, oh, we were talking about the length, now we're talking about how tall it is. Okay, Sydney Harbor Bridge is 134 meters tall. The height of the bridge can rise or fall by 180 millimeters. Because of the changes in temperature, find the minimum and maximum heights of the bridge. Okay, what's the key information? All right, so instead of talking the length of the bridge, now we're talking about the height of the bridge. Okay, so it's 130 meters tall. The height of the bridge can rise or fall by 180. So we're having that rise and fall thing again, right? Which is kind of like that plus minus thing of 180. So that's the distance that it's rising. And notice again, this is in meters and this is in millimeters, so we're going to have to adjust that because of the changes in temperature. Find the, what do we have to do? The answer is the minimum and maximum. Find the minimum and maximum heights of the bridge. So that's what we're trying to do. Find the min and the max. All right, cool. We can do that. So let's go for this. Let me get this problem kind of centered for you. Okay. So think about it. What does it say? It says that it is 134 meters tall. So we have 134 here. And then what happens is it can expand, it can rise 180 millimeters that way, or it can fall 180 millimeters in the negative direction, right? So that, because this is plus and minus, that's what it's going to equal. It's going to equal 180. And then what happens? When it rises, the maximum, it's going to be a new height, right? And we don't know what that is, so we're going to call it X. Or when it falls, it's also going to be a new height. So we don't know what it is. We're going to call that X. But to figure that out, what we're going to do is we're going to take the difference between the actual height and what may occur, which is X. So we're going to go ahead and find that difference again. So X minus 134, we're finding the difference between those two numbers because the difference between those two numbers is 180. But remember, we have to convert that. And then we're just going to take the absolute value of the difference because the difference could be positive and the difference could be negative. So there's two possibilities. So there we go. Okay, so now let's deal with this meters and millimeters bit. Okay, so do you remember what that saying was that I said? Kids have dogs, mothers drink cow's milk. Okay, so we're going to go ahead and convert this to meters again. We are at 180 millimeters, and that needs to equal something meters. Okay, so we go to, oh, this is millimeters. Okay, we go to where we start. We start here at millimeters, right? And we're trying to convert to meters. So we're going from millimeters to meters. So we do the super complex technical method called the Loopy Method. And here we go. Let's start together. We start here and then we go over here. 1 loopy, 2 loopy, 3 loopies. 1, 2, 3. And we went in this direction. So then we go here to 180. We go to the decimal. And we go 3 loopies in the same direction. So 1, 2, 3. boom, that's where the decimal goes. So we go 0.18. This last 0, you don't need to go 0.180. That 0 does nothing. So there we have it. It's 0.18 meters. So we're going to put the decimal right there. So now 134 is in meters, and this amount that it is rising and falling is also in meters and no longer in millimeters. Perfect. Okay, so now we're going to solve it and figure out what that min and max is. So we're first going to isolate the absolute value symbols. Okay. Yeah, we're isolating the absolute value symbols, and once we do that, which we did, now we break it into two equations, right? We keep whatever is in there. We don't change anything inside. That's very key. Do not change anything in there. So that is going to remain the same. So we're going to have x minus 134 equals and x minus 134 equals, okay? And those, it's exactly the same, exactly the same. The thing that changes is this 0.18, because it can rise, it can go in a positive direction, or it can fall, it can go in a negative direction. So we have to have both scenarios represented. So here we're going to have 0.18, and then over here we're going to have negative 0.18, and then we're just going to solve it, okay? So we got to get x. We're going to get x by itself. Right now it's being subtracted by 134, so we're going to do the inverse operation, which would be addition to both sides. We end up with x equals 134.18, okay? Then we're going to do the same thing over here. We want to figure out what x is. So we're going to do the inverse operation of subtraction, which is addition. And then this cancels out. We have x equals, and because this is a positive number and a negative number, we need to find the difference. And I'm going to go ahead and do that over here on the side. So you always put the bigger number on top when you're finding the difference between two numbers. And I'm going to subtract 0.18, so I have to line up the decimals whenever you're adding or subtracting decimals. You line them up, add those zeros, and then we can't, you know, this isn't going to happen, so we have to borrow, but you can't borrow there, so we're going to have to borrow from here, that make this a 3, make that a 10, and then borrow, making that a 9, and this now a 10. And then we have 10 take away 8, which is 2, 9 take away 1, which is 8, and then we have 3, 3, 1. All right, that's the answer. 133.82. So this is the smaller one, so this would be the minimum. Minimum. It's kind of a fun word to say. Minimum. I don't know. Maybe not. I don't know. I kind of think it's fun. Minimum. Okay, so the minimum and the maximum. See, maximum is not as fun to say. Minimum is way funner to say. Maximum, not as fun. Okay, but the maximum is 134.18. All right, there we go. There's our answers. Boom shakalaka. All right, on to C. Let's see here. Can I get this all on the same page? All right, I think that'll work. So, C. It says a support beam for a building must be 3.5 meters long. It is acceptable for the beam to differ from the ideal length by 3 millimeters. Find the minimum and maximum acceptable lengths for the beam. All right, let's do it. Let's do this. Okay, what is the important information? Okay, a support beam for a building must be 3.5 meters long. Okay, so that's how long it is. It's acceptable for the beam to differ from the ideal length. So we know that it's differing, right? That's key. That's a key word, is that it's differing. That's a key word that lets us know that we're dealing with an absolute value equation story problem, okay? That differing, it can be this or it can be that. Boom, you should know it's an absolute value, okay? Anytime you're reading something and you're like, it could be this or that, that's going to be absolute value. Okay. So it can differ from the ideal length by 3 millimeters, okay? Find the minimum and maximum, again, acceptable lengths for the beam. Okay, what's the minimum? It's such a fun word. Maximum, no, not as fun. Not as fun. Minimum. Okay. All right, so let's go ahead and figure this out. Okay, so what do we have? What do we have? What do we have? We have, okay, the beam is 3.5 meters. So I'm going to go here. This is how, this is it. The beam is 3.5 meters, right? And then it can go 3 millimeters this way, or it can go 3 millimeters this way. Right? So we need to find the min, which we don't know. That's our x. That's our variable. No, the max would be this way. I'm sorry. The maximum would be x right here. And then the minimum would be over here. We don't know what that would be, but it would be 3 millimeters that way. So we just need to find the difference between our ideal value and our what the max and the min could be. So we're going to find our difference, right? The difference between two numbers, you just subtract them. And then that difference is what our absolute value is going to be. And it's going to equal the thing that's going to go this way and that way, which is it can go plus in the plus direction, and it can go in the negative direction. So that would be 3 millimeters. So it's going to equal 3 millimeters. But remember, this is in meters and this is in millimeters, so we need to convert. Does anybody remember what the saying is? To convert from millimeters to meters? Kids have dogs, mothers drink cows' milk. Okay, so super complicated method, technical method for converting 3 millimeters to how many meters? We start at the millimeters and go to meters, which would be right here. Start here and go loopies. Yes, loopies. 1, 2, 3. 3 loopies in this direction, so we go to the decimal. And we do loopies, okay? 3 of them. 1, 2, 3, new decimal. There's nothing there. What do we put? Yes, we put zeros. So then we end up with 0.003 meters. And that is what it's going to equal. It's, 3 meters this way, 3 meters that, no, 3 millimeters this way, 3 millimeters that way, which is the same thing as 0.003 meters. So that's what it's going to equal. Perfect. Okay. Now we're just going to solve this absolute value equation, right? The first thing to always do is isolate those absolute value symbols, which they are, which is perfect. So since we have that, we drop it down into 2 equations. Okay. Remember, we're going to write it exactly how it is on the inside, right here, and right here, and right here. I'm going to highlight first. Why not? So x minus 3.5. Okay, that's going to be exactly the same. They're exactly the same. I've never really highlighted and then written in it. It feels weird. You should try it. It's just different. You should definitely try it. Okay. Now when we split it into 2 equations, okay, remember to drop those absolute value symbols, and then it equals, right? And it equals the 0.003 in the positive, and also the negative 0.003. Okay, so yeah, it's positive and it's negative. Okay, kind of had to do a little woo over there, but that's okay. All right, now we have our 2 equations. We dropped the absolute value symbols. We wrote exactly the same thing inside 2 different ways, and we have our positive and negative for this part right here. Now we just solve for x. So the inverse operation of subtraction would be addition to both sides. That cancels. We're left with x equals 3.503. Okay, and then we're going to subtract over here, and I have to go over here to my side, my little side, and do my little side work. I'm doing it on the side. This is positive. Oh, I didn't even solve it. My bad. Okay, we had x by itself, so we're going to add 3.5 to both sides. You're like, Mrs., what are you doing? Okay, that cancels out, and that's 0, and then we're left with x equals, and then this is positive, this is negative, so we have to find the difference. Okay, so we line up the decimals. 3.5 is the bigger number. We're going to put that on top. And then we have 0.003. There's nothing here, so we put 0 because 0 is nothing. And we're going to subtract. All right, so we can't go 0, take away 3. So we're going to have to borrow, but we can't borrow from 0. We're going to have to borrow from the 5, making that a 4. And then we have that becomes 10. We have to borrow from that 10, making it a 9. And now this is a 10. So we have 10 take away 3, which is 7. And then 9 take away 0, which is 9. And then 4 take away 0, which is 4.3. So our answer is 3.497. So that means that our minimum, oh, that's so fun to say. Minimum. I feel like that could be like some type of song or like the back of a song. It's kind of, it just has like a rhythm to it. Minimum, boom. I don't know. Okay, I'm sorry. Okay, back to minimum. Okay, the minimum's right here. 3.497. And then we do the max. This number's bigger, so that's going to be our max. And maximum. Not as fun to say. I'm sorry. I just, there's nothing fun about maximum. No, minimum. Oh, Dragon, you like it. He likes it. Okay, sorry about that. Okay, maximum is equal to 3.503. Okay, and yeah, that's our minimum and our maximum. Perfect. Okay, on to the next equation. What do we have? D? Letter D. Okay, let's go ahead and read it. It says a quality control inspector at a bolt factory. Does everybody know what bolts are? Bolts are in the family of, just in case anybody doesn't know what a bolt is. So you have, I don't even know if I have anything around here. You have like nails, right? So nails are something that it's long, it has a point, kind of a point, and then there's like a thing, and you use a hammer, and you know, it's used to attach things, right? And you just hammer, and then it goes in and holds two things together. So that's a nail. And then you have a screw, which has a screw. They have a variety of, but sometimes it has an X, like, and then it will use a screwdriver or a Phillips screwdriver. This is a Phillips screwdriver. And then there's kind of like this thread. It's like this spiral thing that's going down, and then it like twists in. And so instead of being pounded in like a nail, well, this would be a Phillips screwdriver. It screws in, and then it attaches two things. Okay, so that what is this called? This is called a screw. Okay, and then you have bolts. Bolts are something where usually a bolt has some type of like shape. It's not a circle, so it will be kind of maybe like a hexagon or maybe even an octagon. Let me think. Yeah, maybe an octagon. It might just be a hexagon. But anyways, there's this shape, and then there's this thing, and bolts, yes, bolts I think are threaded as well. I don't know, maybe they have, I don't remember if they're flat or if they have a screw, but they might. So let's just put a pointy end. And I think that they are, oh, I can't quite remember, but they could be threaded. I think they're threaded. I think bolts are threaded. Okay, but it's the way. So use a hammer for this, use a screwdriver for this one, but this has a tool that fits over it that's also in the same shape, and so that same shape fits over it, and then they screw it in with that shape, and so that's a bolt. And a lot of times you secure something, and then you put like this washer, which is like a circle with a hole in the middle, and the bolt goes through that. And then you put it through, and then on this side, you have another thing. This is not getting good. And then it kind of twists, And then if like you had a piece of wood here, you're trying to attach two pieces of wood. Okay, let's just say that. You have the washer, there's a hole, right? There's the washer, there's the bolt, and then you take this thing over here on the other side and you twist it, twist it, twist it until it gets really, really tight with that wood, and then it kind of bolts it in place. So anyways, the bolt factory is just dealing with some little type of, you know, well, sometimes bolts can be really big, right? But there's another piece to that bolt. It's this other thing here that it kind of screws on and it moves this way, and then it holds two things together. All right, so that's what a bolt is. So it says a quality control inspector of a bolt factory examines random bolts that come off the assembly line. Any bolt whose diameter, okay, so the diameter would be the distance from here going through the center all the way to there, okay? You know what? Bolts might be circular. I think they're circular. Let me take that back of this shape. I think what it is about the bolt, I think it is circular. It's that you drill a hole, you put it through, and then this thing you screw on the back side of it. That's what a bolt. That's a bolt. Okay, so it has this extra piece where the nail, you just hammer it through. There's nothing you put on the end. The screwdriver, you screw it in there. There's nothing you put on the bolt. You have this. You usually have a washer. And then that, you know, you have your whatever you're trying to attach together. You put the washer, you put the bolt, you put it through the hole of the washer and through the hole of whatever the two things are that you're trying to attach together. And then this thing, it slides up and locks all that stuff together. So this holds it from the front side, and this little thing right here holds it from the back. So that's a bolt. Okay, so a quality inspector at a bolt factory examines random bolts that come off the assembly line. Any bolts whose diameter, so it's a circle, differs by more than 0.04 millimeters from 6.5 millimeters is sent back. Find the max and the minimum diameters of an acceptable bolt. Okay, let's highlight the important information. A quality and control inspector at a bolt factory examines random bolts that come off the assembly line. Any bolts whose diameter differs, okay, so that has that key word, differs again. So it's differing by an amount of this. So it's differing by this amount. It can be positive that, or it can be negative that. That's what lets you know, hey, we're doing an absolute value equation here, okay? So it differs from what? It differs from 6.5. That's what it is supposed to be. That is the perfect thing, okay? So anything that differs more than this is sent back. Find the minimum, oh, it says maximum. Find the maximum and the minimum diameters of an acceptable bolt. Okay, so what do we have here? We have that the diameter of this bolt is supposed to be 6.5, but it differs by 0.04 this much, 0.04 that way, and this way, 0.04. Okay, and it becomes this new value, which we don't know, which is X. And it becomes this other, but we know it's a maximum, right? And then it goes in the negative direction, which would make it the minimum, but we don't know what it is, so we're going to call that X. So here, we are going to find the value of what it should be, 6.5, and what its maximum or minimum could be, which we don't know, so we're calling that X, but we have to find the difference between those two. We're looking at the difference. So we're just going to find the difference of X minus 6.5. Whenever you're looking at the difference of two numbers, you just subtract them. Yeah, and then we're going to take the absolute value of that, and that's going to equal the positive 0.04 and the negative 0.04. So it's going to equal this. Okay, that's the amount that is going in the positive and the negative direction. All right, now we're ready. Are we in the same units? Oh, that's nice. This is in millimeters and that's in millimeters. What? That is so nice. That is so nice of them. Okay, so we're going to solve this absolute value equation by isolating the absolute value symbols here and here. And it's on that side of the equation, right? So this is where we split it into two equations. Remember, we keep whatever's in the middle, that just stays. And then we write it right here and right here, but we drop the absolute value symbols. And I'm going to do it again. I'm going to write on the highlight. Okay, I'm preparing myself now. And 3, 2, 1, go. Okay, so we write exactly this, x minus 6.5 equals there, and exactly the same thing over here, x minus 6.5 equals, it just feels so weird. It just feels weird. You have to try it on your own, then maybe you'll understand. Okay, all right, so we wrote that. Those are our two equations. Remember, when we do the two equations, the absolute value symbols drop. And then we have to do this 0.04. Remember, it goes in the positive direction, 0.04, and then it also goes in the negative direction, 0.04. Boom, our two equations. Now we're ready to solve them. So we just need to get x by itself. So we're going to do the inverse of subtraction, which would be addition. 6.5 to both sides. That cancels out. We get x equals 6.54. 5 in the tens, 4 in the hundredths. All right, cool. And then we figure out what x is here. So we have to do the inverse operation of subtraction, which would be addition. 6.5, add 6.5. Okay, that cancels out. We have x equals, and then we have a positive and a negative number. I'm going to go over here and do this on the side. So put the bigger number on top, 6.5. Line up the decimals, 0.04. There's nothing here, so we have to add a 0. We're going to subtract. We can't do that, so we have to borrow from the 5, making that a 4, making that a 10. 10 take away 4 is 6. Then we go 4.6. So 6.46. So our minimum is 6.46. Oh, it's just catchy. I don't know. I don't know if it is to you, but to me, it's catchy. And then the maximum. Not fun to say. The maximum is equal to 6.54, but the minimum, sorry, okay, I'll stop. Minimum equals 6.46 and the maximum equals 6.54, and that's the answer. Boom, right there. Boom shakalaka. So, all right, that's it. That's how you solve absolute value equations whenever you're doing problem solving. Look for that keyword of differing, which lets you know that you're doing an absolute value like story problem. All right, cool. We will see you next time. Bye-bye.